Hello students, Mr. Murphy. I'm going to make a couple of videos maybe uh, reviewing everything we learned in quarter one and quarter two. Uh, if you pass the SLO test with flying colors, I will go back and change your grades for all the two big tests we took in quarter two, plus give you a good grade on the third test, and you can skip it. So pay close attention and let's see what's going on here. So the first thing is area. We know the area is length times width or base times height. And we can see on this, we have a box here. So we need to find the area of that box. So it's a length, well, gee, why am I doing this? Why don't I read the question and figure out what's going on? So side EF, that's this one, of square DEFG has a length of 2 centimeters and is, the length of EF is 4 centimeters because this is a study guide, it's changing stuff. So this is 4. And that's also the radius of the circle F. So what is the area of the entire shaded region? So I need to find the area of the square and the area of the circle, but not all of the circle because I've already found the area of this part and added it in. So what's the area of the square? That would be 4 centimeters. So it would be 4 times 4. So you should write 4 times 4. I can't because I don't have the good pen. But the answer is going to be 16 centimeters squared. And then what's the area of the circle? The circle, and this should be written down for you somewhere, is area equals pi times radius squared. So the radius of the circle is also EF. So that's 4. So it's going to be pi times radius times radius. So that would be 3.14 times 4 times 4. So we already know 4 times 4 is 16, and 16 times 3 ends up being, I don't know, 30, 48, about 48, 49. It ends up being 50.12 centimeters squared. But I don't need the whole circle. I only need this part. So that's 3/4 of the circle. So now I'm going to do 50.12 times 3/4. 50.12 times 3/4 ends up being times 3/4 is 37.59 centimeters squared, and then I add that to the 16. So 37.59 plus 16 is 53.59. 53.59 centimeters squared. So when I grade this, I'm going to looking for the area of the box, looking for the area of the circle, finding the part of the circle that you have or subtracting that part, and then adding those all together. Okay? So that's problem number 1. Problem number 2 is volume. For his latest design, a jeweler hollows out the crystal cube beads like the one in the diagram through which the chain of necklace is threaded. The edge of the crystal is 20 millimeters and the edge of the square cut is 12 millimeters. What is the volume of the bead? Provide all evidence. So we need to find the volume, which is a cube minus this rectangle inside. So basically I need to find the volume of the cube on the outside and the volume of the cube, the rectangle on the inside, and subtract them. The outside is easy because a cube is the same on all sides. So it's height times base times depth. So that would be 10. It's 20. So it's going to be 20 times 20 times 20, and that would be 8,000. 8,000 millimeters cubed for 3. And then the square is 12. So it's 12 by 12, but this part is still going to be 20. So that would be 12 times 12 times 20. And that gives you 2,880. 2,880 millimeters cubed. And then we're going to subtract them. So that would be 0, that's going to be a 2, that's going to be a 1, that's going to be a 6. 6,120 millimeters cubed. So I'm going to look for, are you finding the area of the cube? Are you finding the area of the rectangular solid in the middle? And are you subtracting those two things? So we have area and volume. And our next problem is also a volume problem. John and Joyce are sharing a piece of cake with the dimensions shown in the diagram. John is to cut the cake at the mark indicated by the dotted lines. Joyce says his cut will make the pieces 3 times as big as the other. Is she right? Justify your response. So is this piece 3 times as big as this piece? Okay. This is a trapezoid. It's on its side, but it's trapezoid is a triangle cut in half. So we have the triangle cut in half. So that's a trapezoidal solid, and the area of a trapezoid, which should be written on the board, is base 1 plus base 2 times the height, and then you multiply by the length here. So we've got 5 plus 2.5 is 7.5. So I'm going to look for you adding that up. And then you're going to multiply by 6 times 6 is 7.5 times 6 is 45. And then multiply by 10. So the volume of this is 450 centimeters cubed. And then the triangular prism, area of a triangle, times the height. So 2.5 times 6 divided by 2 times 10. So 2.5 times 6 is 15. Divided by 2 is 7.5. 7.5 times 10 is 750. And so is 450 3 times as big as 750? 450 times 3 is bigger than 750. It should be the same. 7.5 times, maybe I did that wrong. So 7.5 times 6 divided by 2 is 225 times 10 is, I did this one wrong, so it's 225 centimeters cubed, and this one is 750 centimeter cubed, and 225 times 3 is 750. So yes, it is 3 times as big, and I can prove it because the volume of this times 3 is equal to or less than the volume of this. All right. So take a little break. I'm going to do the next couple of problems in the next video.